800 tanks destroyed in 3 months, not by Soviet fire, by transmission failure. The field marshal in charge reports this as within operational parameters. This was the reality of German armored warfare on the Eastern Front. The solution existed since 1939, but German engineers changed one invisible detail that turned British brilliance into a mechanical nightmare that crippled the Wehrmacht. February 1943, German mechanical engineer Oberstleutnant Heinrich Müller arrives in Kharkov, sent by the Waffenamt to investigate catastrophic loss rates among panzer divisions. The situation is worse than Berlin imagined. Wehrmacht management logs report losses of 40 to 50% from mechanical breakdown before tanks even engage enemy armor. Tank Commander Otto Karias observed, "We're losing more panzers to drivetrain failures than to T-34s. Crews are abandoning vehicles kilometers behind the line. Some never make it to the front." Field Marshal von Manstein estimates 35% of all deployed armor never completes a single offensive operation. In one documented case, a panzer regiment of 140 tanks receives deployment orders for Operation Citadel. Only 52 remain operational after 2 weeks, a 63% loss rate. The maintenance officer considers this acceptable. The Germans are using a transmission system adapted from a revolutionary British design, the Merritt-Brown regenerative steering transmission. Captured intact in North Africa in 1942, the most sophisticated tank transmission in any army, triple differential, epicyclic gearing, powers the fastest, most maneuverable heavy tank on any battlefield. German transmissions using improved manufacturing methods are failing catastrophically. Gears stripping, bearings disintegrating, final drives seizing solid, steering clutches burning out mid-advance. British transmissions aren't much different in appearance. Same gear ratios, same configuration, nearly identical external housing. But they run for 2,000 kilometers between rebuilds. German copies fail at 400. Müller watches mechanics extract another destroyed gearbox. Commanders file reports of immobilized tanks requiring recovery under fire. The entire Eastern Front armored offensive hemorrhages the one resource that determines breakthrough capability: operational tank hours. He sends a telegram to Berlin estimating 50% mechanical losses. Years later, in his 1958 memoir, Panzer Betrayed, Müller admitted this figure was deliberately elevated to trigger immediate procurement action. Whether 50%, von Manstein's documented 35%, or that specific 63% regimental case, the losses are catastrophic. The British faced no such crisis. German crews capturing intact British tanks find transmissions that shift smoothly after months of desert combat. These gearboxes become more valuable than ammunition. Mechanics reverse engineer them. Engineers request complete units by serial designation. After the capture of Tobruk in June 1942, sufficient numbers of intact Churchill tanks were recovered to equip an entire test battalion, who by autumn 1942 had documented every specification of the Merritt-Brown system for German adaptation. The Merritt-Brown Type H-4 was developed in 1938 by engineers H.E. Merritt and R.J. Brown at the British Tank Mission in Chobham, Surrey. After competitive trials in 1937 through 1938, a test series of 30 transmissions was sent to armored regiments for field evaluation. The British War Office officially adopted it on November 22, 1939, via Procurement Directive WO-MEC-39147. 2 years of testing and refinement before France fell. By 1940, British factories had manufactured thousands of these transmissions for the new infantry tank program. tank crews were issued detailed shift protocols and specialized maintenance tools, a tactical advantage supporting their effectiveness in North African tank battles. The design, regenerative steering through epicyclic gears, power continuously delivered to both tracks, turn radius controlled by differential braking without clutch disengagement. That control method would prove crucial. The interior featured carburized steel gears with ground tooth profiles, tolerance specifications measured in thousandths of an inch, oil passages precision drilled for optimal lubrication flow, every gear mesh surface case hardened through heat treatment. The gearbox housing wasn't cast iron, it was aluminum alloy, ribbed for strength and heat dissipation. The British had specifically required that transmissions withstand sustained cross-country operation in extreme conditions, which determined the manufacturing intensity. The planetary gears featured roller bearings throughout, not bronze bushings. One machinist could complete 2 gear sets per week. A skilled machinist completed 3. Each gear set required 40 hours of precision work, including heat treatment and grinding. The steering mechanism, not conventional clutch brake, but a controlled differential system with helical gears. Hardened steel throughout, not mild steel. Every load-bearing surface engineered to distribute stress and prevent point failures. One transmission runs 2,000 kilometers flawlessly. No sudden breakdowns, no catastrophic seizures, no mid-operation immobilization. A lubrication system designed for sustained combat loads. The oil pump capacity and filter placement calculated for maximum contamination resistance in sandy environments. Even continuous high-speed maneuvering in desert conditions wouldn't starve the gears of lubrication. The precision manufacturing serves 3 critical engineering purposes. First, load distribution. The accurately ground gears distribute torque evenly, preventing stress concentrations. Second, thermal management. Uniform tooth contact prevents hot spots that cause gear teeth to fail. Third, vibration damping. Balanced components reduce harmonic resonance that shatters housings. The design was classified as restricted technical information, with its specifications kept from Axis intelligence until German forces captured examples during the North African campaign. British testing shows minimal failures and exceptional durability. The transmission survives sustained combat maneuvering, sand infiltration, shell shock concussion, extreme temperature cycling. Reliable, responsive, efficient. In 1942, German intelligence officer Klaus Brenner had captured an intact Churchill tank during the fall of Tobruk. After securing the vehicle, engineers realized they possessed the most advanced tank transmission in armored warfare. British technical manuals were recovered from the crew compartment, providing complete specifications and maintenance protocols. Brenner arranged immediate rail transport to the proving grounds at Kummersdorf. German engineers examined the transmission with professional admiration. This was the system giving British tanks their superiority in close-quarters combat. The procurement office moved quickly this time, too quickly. By autumn 1942, samples of the Merit Brown arrived at Maybach Motorenbau in Friedrichshafen. The military demanded German production within 8 months. Specifications were distributed to Maybach, ZF Friedrichshafen, and Zahnradfabrik. However, this much is documented. In winter 1942-43, German engineers began producing their version of the British Merit Brown. German armored vehicle manufacturers initially embraced it with enthusiasm. Revolutionary maneuverability, superior control characteristics, combat-proven reliability in British hands. Engineering committees convened immediately. Eventually, Maybach Motorenbau in Friedrichshafen took the lead. The transmission development section agreed to adapt the design for German mass production. They measured every dimension, photographed every component, tested the steering mechanism, analyzed the metallurgy. Then they redesigned it. German engineers at Maybach in early 1943 create their version. They retain the gear ratios, the epicyclic configuration, the external dimensions, the control characteristics. They keep the differential steering principle, though mechanically simplified. What they change is invisible from outside, the manufacturing standards. The British Merritt Brown uses precision ground gears, each gear individually ground after heat treatment. Tooth profiles matched to theoretical involute curves. Bearing races polished to mirror finish. The tolerances are microscopic, expensive, labor-intensive. The German version uses machine-cut gears finished with minimal grinding. The tooth profiles are cut to specification and lightly finished. Faster to manufacture, requires less skilled labor, dramatically cheaper. Gear housings are cast iron, not aluminum alloy. Bearings are production standard, not individually fitted. The German design was slightly heavier than the British transmission, 340 kilograms versus 295 kilograms for the British version. For transmissions operating at moderate loads, it works adequately. For sustained combat power in battlefield conditions, it proved catastrophic. Oberst-Lieutenant Heinrich Müller later wrote with the authority of a mechanical engineer who witnessed the consequences. As any transmission designer knows, it is unsafe to operate a regenerative steering system with standard production tolerances. The machine-cut gears, flexing under combat loads and thermal stress, develop accelerated wear patterns. Not catastrophic failures initially, progressive degradation, increased backlash that cascades under load. A slow, steady deterioration that multiplies across thousands of transmissions. German engineers also simplify the lubrication filtration system, reducing filter capacity by 40%. They eliminate the pressure relief valve present in British transmissions. They use cast iron housings instead of aluminum alloy, increasing thermal mass and reducing heat dissipation. The inadequate gear finishing is the critical failure. Production begins. Tens of thousands of German-made transmissions shipped to the Eastern Front, Italy, training facilities. Immediately, universally, they perform worse than British originals. The failures aren't dramatic enough to trigger immediate production halt. A slight whine under load, harder shifting into certain gears, a steering response that feels less precise. Multiply that degradation by hundreds of operating hours. Failures become catastrophic. Not as bad as older German designs, but far worse than British Merritt Browns. German copies arrive at the front throughout 1943. As Müller documents the mechanical crisis, maintenance officers sorted transmissions into categories. Captured British units for command tanks, German copies for standard operations with reduced operational range limits, older systems for everything else. The insufficient gear finishing fails identically to pre-war German transmissions. Thermal cycling in combat operations destroys them. Operating temperatures regularly exceed 180 degrees Celsius in the gearbox. Oil breakdown accelerates past 150 degrees Celsius. Metal expands and contracts, tooth-teeth wear. Microscopic imperfections become visible damage. Müller's February 1943 alarm telegram reaches Berlin. His 50% estimate, admittedly designed to provoke alarm, wasn't far from documented loss rates of 35% or that specific 63% regimental case. The Wehrmacht High Command finally notices, not because of 1942 warnings, not because of obvious British engineering superiority, because panzer divisions are losing operational strength to mechanical failures faster than combat losses. Tanks aboard attacks due to transmission trouble. Crews abandon vehicles before reaching assault positions. In July 1943, Operation Citadel requires 2,000 operational tanks for the Kursk offensive. Only 1,400 are mechanically sound enough to advance. The offensive stalls partially due to insufficient armored strength. Maintenance crews work around the clock. Supply trains carry triple the spare parts because everyone knows transmissions won't last their rated hours. Divisions operate at 65% strength because tanks are perpetually deadlined for drivetrain work. The response isn't halting German production. The response is letting captured specialists handle it. Occupied Czech factories in 1944 begin producing faithful copies of the British original under forced labor using captured specifications. Precision ground gears, full filtration systems, proper bearing tolerances, no manufacturing shortcuts. By mid-1944, 15,000 Czech manufactured transmissions shipped to the Eastern Front. By autumn 1944, transmissions were being refurbished in captured Polish facilities. Tens of thousands more follow for the defense against the Soviet advance. These Czech transmissions work. They don't strip gears. They survive sustained combat maneuvering and shell concussion. They run for 2,000 kilometers. They deliver precise control consistently. Everything the British original was, now manufactured by Czech technicians. German production continues making inferior machine-finished versions alongside Czech precision ground versions. A single Panzer division requires approximately 400 transmissions annually, accounting for combat losses and scheduled overhauls. The reliable transmission shortage would haunt German armored operations throughout the Eastern Front campaign. In June 1944, lack of operational tanks caused by mechanical failures actually limited the armored reserves that could be deployed against the Soviet summer offensive, even though replacement vehicles sat in depots waiting for transmission swaps. The strategic defense required mobile armored reserves. Divisions couldn't maintain operational readiness. By December 1944, maintenance logs showed transmissions averaging 500 kilometers before failure, 1/4 of British transmission longevity. According to official engineering reports, the problem stemmed from insufficient attention to manufacturing precision and thermal management in license-produced foreign designs. By VE Day in May 1945, over 80,000 transmissions of various types were required to maintain armored operations across all fronts. Total German production of Merritt-Brown-derived transmissions reached approximately 42,000 units of varying quality levels. General Heinz Guderian observed in March 1945, "Without reliable powertrains, armored warfare is impossible. We learned this lesson too late and at catastrophic cost." The exact number of tanks lost specifically to German machine-finished transmissions cannot be calculated from surviving records. But Müller noted in his 1958 memoir, little about the transmission adaptation program appears in the official war diaries. The procurement offices that rushed production continued minimizing documentation of the engineering failures. What is documented? Severe German mechanical loss rates in 1943 through 1945, British transmission superiority, Czech manufacturing of proper precision ground copies by 1944, eventual marginal reliability improvement in late 1944. The British Merritt-Brown succeeded because Merritt and Brown understood that every detail matters in combat conditions. The precision grinding wasn't optional. The individually fitted bearings weren't optional. The aluminum alloy housing wasn't excessive luxury. Everything served a purpose, tested under extreme conditions. German engineers kept functional principles and changed manufacturing ones. They assumed machine-finished gears would suffice. They assumed simplified production would be acceptable. They assumed the details didn't matter as much as overall mechanical design. They were wrong. While exact statistics remain fragmented, consequences were measured in tanks abandoned during advances, offensives stalled for lack of operational armor, and German crews requesting captured British transmissions over domestically produced ones. This is what happens when design is copied but not craftsmanship, when production speed is prioritized without understanding why every manufacturing decision was made, when close enough is assumed without endurance testing. Post-war armored vehicle specifications governing transmission construction eventually mandated precision ground gears and individually fitted components, effectively abandoning the German wartime mass production approach. The lessons learned influenced every subsequent German vehicle program. Post-war Leopard tanks used precision manufacturing. Modern automatic transmissions learned from these mistakes. Contemporary armored vehicles are machined to tolerances the 1943 engineers couldn't achieve. Britain created a masterpiece through necessity and meticulous engineering. Germany initially botched the copy through cost-cutting and production pressure. The design that prevailed was the one where every detail had a purpose. Engineering details matter. Manufacturing shortcuts have costs. Sometimes the best approach is faithful replication of proven excellence. The Merritt Brown story reminds us that invisible manufacturing choices often matter more than visible mechanical principles. That institutional pressure to accelerate production carries real consequences. That in engineering, as in war, details determine outcomes.